Hello, it's Keith from Kinvert. Another quick one for you here. I've started doing some more stuff in CUDA, and you can find it in the link below in the GitHub. So in this case, I'll show you the code here. And so basically I'm doing numerical integration and doing it with CUDA. So you can see the code here. I'll go over it after I show you the results. So this is with only like 10 slices. And so I'm going to compile this, and so that should have worked, and I should be able to run it, and we see that it worked. Now the correct answer is 1/3, so it'd be 0.333, repeating of course. But so there you go, and then we can go in and actually edit this and increase the number of slices here, and it should get closer theoretically. I haven't tested this, but it should get closer to 1/3 if I run it like this, and it did. Alright, so that's the result. I'm going to go over the code now, and I'll link to this from the GitHub so you guys will be able to see that. Alright, so I first tried this with ChatGPT and it wasn't working. It was able to do it in C++, but not in CUDA for some reason. I've got the stdio because of my printf towards the end. This is the kernel here, and it's bringing in a and b, which are the lower and upper bounds, and is the number of slices, and then it's got the sum in there. So we take the thread ID, and this is the standard way of doing it, and then we are finding what's our dx, like what's the actual width in the x direction of our slices, and then we're making sure that I don't have some thread ID that's too high and then messing up the sum. And we're basically just taking that lower bound, and then we're saying, you know, how many slices over are we and what's the width of that slice. That's getting us the x value at where we're at. And in this case, the function is just x squared. That's what ChatGPT had chosen for its C++ example. So I was just doing something that's similar. And then we're basically putting that value in, and we will later sum it. So now we've got like basically an array of values, of double values, that we will later sum. And I'm just making sure that the threads are synced here so that we're not running through this before everything has been added up. And so that's the kernel that we'll be running here. So here I'm just setting the lower and upper bound, and these could be basically whatever. It's, you know, x squared, it's a continuous function. And we've got n is 1000. In this case, at first it was 10. And then we're basically making these empty values where this is where, so we're just saying we're going to have n doubles, and we are allocating the memory into the GPU, and then we are copying. Now there's nothing in there to copy, but we're copying into the device from the host. So we're copying from the CPU to the GPU. So the value of hsum, which is just empty, we're copying into dsum. And then we're actually running this. And I think this is straightforward for anyone who's seen CUDA. But basically we're telling it what size we're sending in. And this is basically telling it the block dimension. This will be, I believe, the grid dimension, which is just saying we just have one block. And then the n here is saying we have this many blocks. Now, what it will do is it'll go to the nearest, I believe, multiple of 32. And so we could have too many threads in here, and that's why I have this, to make sure that we're not going over, because this will maybe end up at, like, say 1024 instead of just 1000, if that makes sense. I believe that this will go to a multiple of 32 in real life, the number of threads here. And then we're just saying this is the size of what we need to, oh, wrong line, we already did that. We're putting in that, and then the sum that we haven't summed yet. Where are we at? Less than 5 minutes. And then we get the results. We're copying from dsum into hsum. So we're basically copying from the GPU to the CPU, and we're saying the size of what we're grabbing, and we're saying the direction. So we're going from device, from the GPU to the host, to the CPU. And then we just sum. Hopefully that makes sense to you. If you're in CUDA, if not, go look up some C++. But this is just a basic loop in C++. And then I'm just printing the value and freeing the memory. So Hope that made sense. Tried it with ChatGPT, it just wasn't working. They did actually write a program, and that was this O2 version, and this one didn't work, and I tried multiple times. You can see the comments and stuff, and it just didn't work. But the O1 version, the C++, this worked, and so you can see it's pretty straightforward. And then I might change this later, I don't know yet, to compare how fast they are, especially if we get a higher n value here. That could matter. And then I might rewrite this also, the CUDA version, to deal with like shared memory and stuff that could make it faster, especially if we're getting into higher n values and stuff. You could look into more optimizations. But anyway, this video's been long enough. I'll just quick show you this. You can go follow this if you want to, hit star or whatever, so you'll be able to kind of see what's going on. But this is just one of many things I've got in here. ChatGPT actually wrote this, including the latex. It's pretty cool, or LaTeX, or however people say it. And it wrote the explanation, including this. Now, I had to give it my code, and I'll have to update this because I actually had somewhat messy code because I started from what ChatGPT had written, and it was a mess, and I didn't realize it until I actually looked at this in the README. So I'll have to probably redo some of the README a bit. But overall, it wrote the README, even if the CUDA code wasn't correct. But still, it was helpful. I tried a little too long to get it to work just with ChatGPT, but it did outline the code, and I was able to get it done quicker probably than I would have if I wrote it from scratch, because it did get it somewhat close. But there was still quite a bit that needed to be fixed. But anyway, hope you guys found this interesting. I'll keep making more stuff like this. Check out the link below for the GitHub. You'll be able to find all the code and more. There's plenty of stuff going on here if you guys are interested, so check that out. All right, Keith from Kinvert, and I'll see you guys later. Bye-bye.